Hello, Chemistry 10 and Chemistry 10H students. This is Mrs. Altman, and this is the second video on double replacement reactions, where we will focus on writing the spectator ions and the net ionic equations. So the spectator ions are just the ions that make up the soluble product. They are called spectator ions because they actually do not react between the reactants and the products. They are just sitting there watching, hence the term spectator. To write spectator ions, all you do is you look at the aqueous product and you list the ions that are in them, which is why it's oftentimes a good idea to include your pre-work. Okay, let's take a look at an example. So I have two completely balanced double replacement reactions. These are two separate problems. I hope that was clear from the way it's outlined. So for the first one, I'm ignoring the reactants. I do not care about the reactants. I just look at the product. I don't care about NGS because it's a solid. I only care about the Ki. And then I just list out the ions. So K plus I minus. This is not a reaction. You don't need to balance it. You don't need to put states. You just list the ions. So this is the answer for the first one. Then for the second one, I see that there are not one, but two aqueous products. So I'm going to have to list all of them. If I had the room, I'd put them all on one line. So when you have two aqueous products, you will have 4 spectator ions. In the rare case where you have two solid products, meaning no aqueous, you will have no spectator ions. You would just write no spectator ions. Sometimes that happens. Right, then net ionic equations. It's sort of like the opposite of the spectator ions. So that's what happens when you remove the spectator ions from both sides of the equations, as opposed to molecular equations, which include the spectator ions. So what we did last video is called molecular equations. Let's take a look at an example with it. Right, so we're going to write all of the parts of this. So let's start with the pre-work. I'm just listing out all the ions. It's really useful when you have to do all parts of it to list the pre-work. It's the molecular equation. I'm not going to do this super in detail since we have the whole other video of it, but I'm crisscrossing Ba with OH. Don't forget the parentheses around hydroxide since it is polyatomic. If I go to my solubility rules, sulfur is mostly insoluble and barium is not an exception, so that will be solid. And then hydroxides are mostly insoluble and magnesium is not an exception, so that is also a solid. This doesn't happen very often. Since there are two solid products, there will be no spectator ions. Sometimes it happens. And then typically you just have one net ionic equation, but here I actually have two. So I'm going to do, it doesn't matter the order I do them in, by the way. So I'm going to start with BAS just because it's the one that's first in the way that I wrote it, but I could have just as easily done the other one first. And then on the left side, I just put the ions that make it aqueous because this is double replacement reactions, and then balance it if need be, but I didn't need to here. And then I just do the same thing for the other solid product. Aqueous because we have the reactants here. And then I just need to go ahead and balance it, so I put a 2 in front. So this is not a super common case where you'll have two net ionic equations, but it can happen. Let's take a look at the next one. So just following the same sort of principles that we've been following. And then keep in mind that we do have to simplify, so it's going to just be FePO4 and not Fe3 parentheses PO4 close parentheses 3. I go to my solubility rules. Lithium is always soluble with no exceptions. I don't have a rule for iron, but I do have one for phosphate that it is mostly soluble. Iron is not an exception, so that's solid. And then I need to balance it, so I put this 3 right here. Now for my spectator ions, I've got one aqueous product, so I just list the ions, so just Li plus, Cl minus. I don't need to do any sort of balancing for them. And then for the net ionic equation, I'm listing my solid product. And then on the left side, I put the ions that make it, which is why I like to have that pre-work there. And then this is already balanced, so I don't need to do anything more. All right, thank you so much for watching and have a great night.